With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, today our question is a charged particle having some mass is resting in equilibrium at height h above the center of uniformly charged non-conducting horizontal ring of radius r here, and the equilibrium of the particle will be stable for A, B, C, D option is given here, so we have to find which option is correct. So the solution of this question is, let us suppose here is our Q into E, that is charge, and E here, this is our positive charge, and in this direction Q and E, and in downward mg is acting. So this is the mg here downward, and here we have the uniformly charged, that is charged equilibrium here. So this is plus Q, and this is uniformly charged, this is plus minus plus minus plus minus, and this type, this is in circular ring, this is air, and we can write the conditions for the height and r. So firstly we can write here, for uniformly charged ring we know that potential at a distance h from the axis is E, and we have the E is equals to E denoted here potential, and this is equals to k time of Q, and this is h, and this is divided by r square plus h square here. So firstly we check if the function has the maximum value. This function has maximum value when the our height h is equals to r divided by root 2. So at this position function has maximum value here, and maximum force is maximum, and the area under EH curve, that is potential energy curve, is maximum. So we can write here, under this we have potential energy curve, potential energy curve is maximum. Now we check for two condition, when it is, we have to give the condition when it will be stable. So we know that if h is less than under root r divided by 2, in this case we displace the particle slightly downward, and so upward QE force will also decrease, so particle will start moving. So this is type of, we can suppose this, if we displace slightly down, suppose in this direction we displace our particle, so downward, E will decrease. So in this case, E will decrease, that is potential will decrease. And so in upward we have the QE chart, QE acting, QE act, that is Q charge into potential is also decreases. So this is also decreases here, and so the particle will move finally in this direction like this, downward away from the equilibrium. So from this we can say that in this case we get unstable equilibrium. This is unstable equilibrium here. Now if H is greater than R divided by 2, so in this case we displace the particle slightly upward. Suppose this is our particle here and we displace this slightly upward, so E decreases. So in this case E decreases, and that is potential decreases. So QE, that is this is acting in this direction, force is also decreases, and the particle will move downward towards the equilibrium state. So this is in this direction towards the equilibrium state. So in this case we get stable equilibrium. Now we can draw the curve for E and H. So our curve is something like this here and this. So this is in this y-axis we have E, and in x-axis we have H. So we have to draw 3 points here when H is less than under root R by 2, R by under root 2. That is our first condition here, that where unstable equilibrium will be there. R divided by under root 2. And here we have H is equals to R divided by, and here we have R divided by under root 2. So here also it is R divided by under root 2. So our curve is here. Then at this point maximum, then it move slightly like this. So we can join this. At this point we have the maximum and this point is here. So this is the graph for it. So our answer is we get the stable equilibrium if we have R is greater than H is greater than R divided by under root 2. So we get stable equilibrium. So this is our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.